Welcome. In this video, we're going to look at a projectile kind of a question which says, this is the figure. This is the figure that has been given, and we're told to show that the maximum height is given by this expression, and also the time of flight is given by this, and the range is given by this. So we have been given a projectile which is projected at this initial velocity at this angle. So now we have this one, which is the range and the maximum height, and this is the range, which is this, and also the maximum height is this one, and the time of flight is this one. So in this video, we are going to show these. So from this, what we're going to do is we are going to this one. Okay, we can do something like this, of which this is like this, where we have this theta, and then we have this one. So now, what we need to do is we need to express this in terms of the vertical and horizontal components, or x, y and x, the x and y components. So here we have the x component, and here we have the y component. Now, from the aspect of SOHCAHTOA, sine theta is equal to opposite over hypotenuse. So we have y over the v naught, which is the initial velocity. So y is equal to VO sine theta. So this is the vertical component, which is this one. Then we go to this one, to x, which is cos theta is equal to the adjacent, which is x over hypotenuse, which is that. Then from here, this one, the x will be, because when we cross multiply here, we're going to have VO cos theta. So from here, we can now proceed. So we know that, let us begin with 1. The maximum height. So the maximum height, it is the height that will be attained when an object stops moving here. Because at the maximum height, the object will stop moving. So we are going to have v squared is equal to u squared plus 2ax. So here, what we have, where there is u here, we can also put the v naught is equal to the v naught. In fact, it is in the y direction, so v naught, or simply the vy squared plus 2ax. Now, at the maximum height, here, the velocity is going to be 0, because it will stop, then start coming down. So from here, what we're going to do is this one, the vy, it is this one. We have VO sine theta squared plus 2. Now, this one A, the acceleration, it is the acceleration due to gravity. The acceleration due to gravity, and when it is moving upwards, the acceleration due to gravity is a negative value, and the x is simply the h max, because this is the maximum height that is going to be attained. So from here, what we're going to do is 0 is equal to, so when this is squared, we're going to have VO squared sine squared theta. Then when we multiply this, we're going to have minus 2gh. So when 2gh crosses the equal sign, coming to this, we're going to have a positive 2gh. So this is the h max is equal to VO squared sine squared theta. So from here, we can divide by 2g, even here by 2g. So that this and this will cancel. So of light, we know that x is equal to ut plus half at squared, where when a projectile moves from here, coming to the maximum point and coming back to this, the total displacement is going to be 0. And here, for this one, we are going to make use of the initial velocity, in fact, the velocity, the vertical component of the velocity, which is VO sine theta as we derived it, then t plus the half times a. So the a that we're going to consider is the acceleration due to gravity, and since it is moving up, So it is a negative g, then t squared. So from here, what I'm going to have is 0 is equal to VO sine theta t minus half gt squared. So this one can come this side, and we're going to have half gt squared is equal to VO sine theta t. So from here, we can multiply by 2 and also by 2 here, so that we have gt squared is equal to 2 VO sine theta t. So like this, and this can cancel. And we're going to have is here, let's just divide by g, and here by g. So that this and this will cancel, and what we're going to remain with is a t, which is the time of light. So 2d sine theta over g. And this is an expression for the time of flight. And finally, let us derive the formula for range, for the range. So let me just do this. So 3, the range is given by Vx then times time. So the Vx that we found even from Sokatoa, right from the beginning, we say Vx is equal to Vo cos theta, then t. But the value for time, in fact, the expression for time is the one that we are just from deriving, which is this one. So we just plug in this. We are going to have Vo cos theta times this one, which is for t, to Vo k. So from here, what I'm going to do is we're just going to multiply. So V naught cos theta times 2V naught sine theta. What I'm going to have is 2V naught squared cos theta sine theta over g. And this is the expression for the range. So this is for the